Okay, so let's discretize the basic partial differential equation of du by dt is k d squared u dx squared, the diffusion PDE for a field u as a function of x and t. We're going to discretize it in both space and time, and in particular we will deal with or find values on the grid, u, j, l, which is u at xj and time TL. So here's a little piece of the grid. You can see we've got xj minus 1, xj, xj plus 1, and they are separated by grid spacing h. We've also got times TL, TL plus 1, and so on. They are separated by a time tau. And what we're going to seek is the grid values. So the value of u at this point is u, j, l. The value at the u at xj minus 1 TL is u, j minus 1l. Value at xj plus 1 is u, j plus 1l. And then at the next time step, we'll be looking for the value of u, j, l plus 1, u, j minus 1l plus 1, u, j plus 1l plus 1, and so on. Okay, for our discretization, our first discretization is only going to involve these four values. And it's going to occur by looking at the PDE at that point, at xj TL. So for example, du by dt at xj TL we'll denote by du by dt jl, and so on. Okay, so if we're going to try and solve the PDE using a discretization, we have to approximate these derivatives. And the approximation we're going to use is firstly the standard approximation for a second derivative, that is 2x derivatives are u of x plus h, t minus 2u of xt plus u of x minus ht all over h squared, and that's approximately. And that du by dt is approximately the difference in these two values divided by the change in time, which is tau. So that'll be u of xt plus tau minus u of xt divided by tau. Right, so now at this particular point, so that's xj/TL, the partial differential equation is replaced by this right-hand side approximation. All right, so the PDE becomes du dt at that point, so that is u at x t plus tau, so that's u j l plus 1, minus u at xt, which is that point, so that's u j l divided by tau, and that should be equal approximately to k, two space derivatives, which is this expression, which is the second difference in space among these three values. So that'll be 1 over h squared into u j plus 1l minus 2u jl plus u j minus 1l. Right, this is the discretization. It's more convenient rearranged. Multiply by tau, and then call this combination S. Right, so we set S to be k tau over h squared, and then this equation becomes u j l plus 1 minus u j l is equal to S u j plus 1 l minus 2 u j l plus u j minus 1 l. And finally, just move that term over on the right. u j l plus 1 is u j l plus S uj plus 1 L minus 2 uj L is uj minus 1 L. Right, and this is now computational discretization. What it does, if we know these three values at time L, then we can compute this right hand side, and that right hand side estimates uj L plus 1 to give us that point. And similarly for all other triples at time L, they will give us each of these points at the next time.